Hello everyone and welcome into yet another live stream, and music is a bit loud. There we go, that's much better. Hello everyone, welcome into yet another live stream. Hi there, on the side. Hi Ali, hi. Hi. Yes, sip. So let's get straight into it, shall we? So we will need this and this. That's wrong. Why is this? Come on. Workbench. Workbench, that's what it's called. Firefox, Zero Science, Political Engineering. There we go. So, more study. Heck yeah! 4th main channel live stream in a row. Can you believe it? We're actually learning stuff. Wow. Anyone remember where we ended up last time? Like, what was the last chapter? We're still in the first one, I remember that much. Measure of matter, meaning of measure. I think the... Oh my goodness, we're finally getting the 3rd sub-chapter. So far we are going 1 sub-chapter per stream, which is... just... Okay. So, the last note... Yes. Okay, distillation, crystallization, so ways of separate. Oh yeah, we've been over this. This is the basics. Then we have this, which is significant figures and rounding off, which is also basics, right? Yeah. Yeah, okay, this is also basics. I'm open. Alright. Top of demo. Yeah, I remember that. There's some heat and stuff. But then we moved on to more, and then... Right, running more running examples. Running to of key figures is uncertainty. Yeah, so uncertainties and rounding, cool. Basics of chemistry. We're finally getting into chemistry. Oh yeah, I'm excited. How many chapters? Only 2. Whoa, boy, the 2nd chapter is gonna be just fun, isn't it? We're gonna learn about the moles, everyone. We're gonna learn about moles. You know how I love my moles. Okay, about atoms. No, wait, we need to go to this one. Okay. No, you know I love my moles, right? That's great. Yeah, I love them. I love them. Okay. Parallel concept of the element and the atom considered the very foundation of chemical science. As such, the concept of element is a microscopic one that relates to what we can observe physical senses. You know what? Let me take a pill. No. I thought I could do it, but I can't. Where's my... There they are. I'm running out. We could refill some. So we're already starting with chemistry, which is great. That's really great. Alright. That's the actual physical particle that is unique to each chemical element. This very small size has long prevented atoms from being observable by direct means. Not universal, except until the late 19th century. The fact that we still hear about mention of the atomic theory of matter should not imply that there is now any doubt about the existence of atoms. Few theories in history of science have been validated and are as well understood. Okay. Yeah. I'm working on the video about this, so I kind of know how this atoms became real. Get real. Okay, this is history of chemistry. Or maybe not. Laws of chemical change. Okay. Looks interesting. Recall that law in the concept of science is a relationship discovered through experimentation that is sufficiently well established to be regarded as beyond question for most practical purposes. Makes sense. So conservation of mass energy is usually considered the most fundamental law of nature. It is also a good example that of a law that had to be modified. It was known simply as conservation of mass until Einstein showed that energy and mass are interchangeable. E equals mc squared. Beloved by everyone, however, the old term is perfectly acceptable within the field of ordinary chemistry, in which energy changes are too small to be measurable effect. To have a measurable effect on mass relations. I'm waking up, okay? Well, it's a warm-up right now. We're in the warm-up section of the live stream. Okay. So mass and energy have to be conserved. Or rather, mass to be conserved, but energy and mass are unchangeable. got it. Mass conservation has special significance in understanding the chemical changes involving gases, which were for some time not always regarded as real matter at all. Owing to very small densities, carrying out the actual weight measurements on gases is quite difficult to do, and was far beyond the capabilities of early experiments. That was when magnesium metal was burned. Yeah, the weight of okay. Makes sense. So this is all just history. Too small to be studied directly. Relative masses, observing. Okay, yes. So we have relative. We need to know the formulas of compounds we are considering in order to make valid comparisons. For example, we can't find relative masses of any two atoms, X and Y, that combine with oxygen only if we assume that values of N into formulas are the same. Very relative mass we in these formulas. Okay, so and hope that enough one-to-one compounds would be found to provide a starting point for comparing the various parts of combining weights. So we need relative mass. Okay. Okay. I don't really get exactly what this chapter is about, honestly. I mean, it feels like introduction to chemistry. Mass number 7 nuclide of nitrogen. Any nuclei is current number 3A. Zillion. What would be the weight of equal number of lithium atoms? Yeah, so this is all just basic chemistry. Like real basic chemistry. I'm not really finding anything. I don't want to skip over this entire chapter, but at the same time, I don't want this lesson just turn into like the reading of a book, right? We're here to learn, not to read over the academic weights. Slightly more slowly than lighter ones, not give enough time for the process. Is there anything? I don't see anything out of the ordinary. Okay, so now it's time for the Avogadro's number, which is just great. Alright. So it's time we learned about the moles. And we all know how much I love my moles. Owing to their tiny size, atoms and molecules cannot be counted by direct observation, but much as we do when counting beans in a jar, we can estimate the number of particles in a sample of any element or compound if we have some idea of the volume occupied by each particle and the volume of the container. Once this has been done, we know the number of formula units, to use the more general term, for any combination of atoms we wish to define in any arbitrary weight of the substance. Okay, so once this has been done, we know the number of formula units, to use the most general term, for any combination of atoms we wish to define. Formula units... this is... My brain is not processing this sentence right. Okay. Formula units being the most general term for any combination of atoms that we wish to define. Okay, we know the number of formula units in any arbitrary weight of a substance. The number will of course depend both on the formula of the substance and on the weight of the sample. However, if we consider weight of substance that is the same as its formula, molecular weight expressed in grams, we have only one number to know, Avogadro's number. Chemists are great at explaining stuff. Okay. So, I know what Avogadro's numbers is, but this is making it harder to understand. So, the rough idea being that different atoms have different mass, weight, volume, whatever. And so the same, let's take volume for example, the same volume of iron will have a different amount of iron atoms than a cube of the same volume of palladium, for example. Yeah. Okay, Avogadro's number is known to 10 significant digits, however you only need to know 3 significant figures. Of what? Well, anything you like. Apple, stand, sky, burritos. However, the only practical use for that number is to have a more convenient way of expressing the huge numbers of tiny particles such as atoms and molecules that we deal with in chemistry. And that's because moles are not a unit, it's a constant. Avogadro's number is a collective number, just like a dozen. Students can think of 6.02 times 10 to the 23rd as chemist's dozen. Yes. Of reasoning embodied in following examples. Alright, let's go with examples. I don't like moles. I don't like them. I understand them, I get how they work, but I don't like the fact that they are units. Okay, the atomic weights of oxygen and carbon are 16 and 12 atomic mass units respectively. How much heavier is the oxygen atom in relation to carbon? Trying to do math in my head because I'm so smart. How much heavier is the oxygen atom in relation to carbon? 16, 12 atomic mass units. 1.5 would be 18, 1.3. 1 and 1/3 times. Oh, heavier. I'm intelligent. It took me such a long time to figure this out in my head because I'm struggling, okay? This is still the warm-up section of the live stream. The absolute mass of carbon is 12 unified atomic mass units. How many grams will a single oxygen atom weigh? Absolute mass of carbon is 12 units or... Okay. So this is molar mass, right? How many grams will a single oxygen atom weigh? No, oh wait, no, this is just unit conversion. Yeah, this is just unit conversion, so this is boring, okay. This moles, who's boss? It's not difficult, it's just, I don't like moles. No one likes moles. But I don't like them for a different reason. They're just masquerading as the units, those fakers. Anyhow. Okay, so this was just unit conversion. And atoms would have a mass of... And this is... Hold on, what? N is a number large enough to give us a pile of carbon atoms whose mass is 12 grams. How much would the number of N oxygen atoms weigh? This is all so simple. Numerical value of N in example... Avogadro's number? Wait, isn't that... I don't remember exactly what unit is Avogadro's number for. Is it really... per gram? No, that's based on unit conversion, that's right. Nah! 63 10 to 23rd? Come on. Ah! Knew it! I'm a smart boy. I'm such a... Oh, hold on, I skipped over something. Alright. It is numbered as a dozen, that's dimensionless. It's a huge number, far greater in magnitude than we can visualize. Its practical use is limited to counting tiny things like atoms, molecules, formula units, electrons, photons. The value of Avogadro's number can be known only to the precision number atoms measurable. Alright, moles and their uses. Oh, yeah. Okay, the mole, abbreviated mole, is the SI measure of quantity of chemical entity, which can be an atom, molecule, formula unit, electron, photon, apples, bananas, stars in the universe, planets, or anything else, because it's so vague. 1 mole of anything is just Avogadro's number of that something. If you think like a lawyer, you might prefer the official SI definition. The mole of amount of substance of a system which contains as many elementary entities as there are atoms in 0.0212 kilogram of carbon-12. Moles are the damn it. They're not a unit. They're not a unit. They're no. I'm fine. I'm fine. No, I will not. I will. I'm fine. Mole is not a unit. It's not a. Why would it be the size? It's a measure maybe, but not a unit. It's not a unit. It's not a unit. Okay. Avogadro's number, like any pure number, is dimensionless. However, it also defines the mole. So we can also express Avogadro's number as 6.02 times 10 to the 25th inverse mole. He was not fine. I'm fine! I'm alright. It's all good. It's all good. This construction emphasizes the role of Avogadro's number as conversion factor between number of moles and number of entities. Okay. How many moles of a nickel atoms? How many moles of nickel atoms are there in 80 nickel atoms? And that's well, it's like it's. That's precisely what I mean. When you introduce a mole as a unit, it becomes so much more complex than as a just constant. Look at this question. How many moles of nickel atoms are there in 80 nickel atoms? See how dumb this sounds when you introduce it as a unit? There, everyone right now, read this question out loud. And if you still think that mole is a unit, then I don't know what to tell you. You know, I just... You do you, I guess. It's so dumb. It's... Imagine if this question would be how many... Okay, this is kind of like a question of how many dozens of nickel atoms are there in 80 nickel atoms, right? Like, yeah, it is a question, but how many dozens of nickel atoms are there in 80 nickel atoms? You already have the number. It's 80. It's 80 nickel atoms. So why would you divide into dozens? I mean, you can if you want. But why would you turn into... Imagine if dozens were a unit, okay? It's... I don't like moles. I don't like moles. I mean, I like them. If not for the fact that they're considered a unit, which they're not. They're not a unit. They're not a unit. Make it. It's fine. It's fine. You can calm down. It's fine. It's... Moles are not a unit. It's not. They're not. They're not. It's the government. I'm good. I'm good. Yeah. Moles are not a unit. They're not a unit. They're not a unit. We're all... We're all fine. We're all having fun. We're all having fun. This is a fun night live stream where we don't have to think too hard because it's a fun. You know, let me move the day over into the corner because I feel like it's covering some of the text every now and then. It's fine. We're having fun. We're having so much fun. Oh, hold on. You know what? I almost forgot. Let me just also switch it to dark mode. There we go. Is it better? I feel like should be better. There. You are all welcome. Okay. Moles are not the units. Okay. Atomic weight, molecular weight, or formula weight of 1 mole of the fundamental units, atoms, molecules, or groups of atoms that correspond to the formula of a pure substance, is the ratio of its mass to 1/12 of the mass of 1 mole of carbon-12 atoms. And being a ratio, it is dimensionless. But at the same time, this molar mass, as many now prefer to call it, is also the observable mass of 1 mole, Avogadro's number, of the substance. So we frequently emphasize this by stating it explicitly as so many grams or kilograms per mole. Grams per mole. Now, once again, I would like to remind everyone that mole is not in fact a unit, even though many people would like you to believe that it's a unit. It's not. So you can think of it as mass per atoms. Okay? That's the actual... that's the actual representation. Mass per atoms. Okay? The mole is just there to confuse people, because... why not? Okay, so this is basically mass per... or per molecule, per particles, per substance, basically. Alright, and so bear in mind that mole is a number and not a mass, but each individual particle has a mass of its own, so a mole of any specific substance will always correspond to a certain mass of that substance. You can see how having mole as a unit is confusing. I'm not blaming this textbook, I'm blaming the SI system, and they just wanted 7, and that's why they included moles for some... It's fine, it's fine. Borax is the common name for sodium tetraborate. Okay, how many moles of boron are present in 20 grams of borax? Are we gonna solve this? I mean, we can, I suppose. Grams of boron are present in 20 grams of borax. How many moles and how many grams? Wait, this is... okay, this is actually funny. Hold on. Let me bring up my paint. Let me bring up paint for this. That's a phenomenal question. Let's see. Let's see if I'm smart, if I can do it myself. So we have Na2B4O7. Then we have question A and question B. How many moles of boron are present in 20 grams of borax? So first we would need to figure out... oh, the unit conversion is gonna be so fun. Okay, if I know how to do it, do we need to go through the whole unit conversion process from atomic mass to grams? I could convert grams to atomic mass units. Do it at least once. No, but it's just such an annoying process. Fine, fine. So first, where's the constant? Where's the constant? Then you'll be good. No, because it's just an annoying process. It's basically you have grams to atomic mass units. You have this. Oh wait, there is... oh yeah, I forgot. I just have conversion stuff, right? That's precisely what I meant by it's annoying, because... yeah. It's a lot of 10 to the powers. And it's not fun. But it's fine. Wait, plus 25 in this case means 10 to the negative. So, because we have an O. Which means 20 grams would be equal to the whatever number it is. You know what, I'm just gonna note this down as X of... because I don't fancy taking that number again. So X units, and then what we need to do is we need to get the atomic mass unit of this molecule, which will be equal to Y, and then we take the atomic mass number, we divide it per each molecule, and then we basically get the amount of molecules. Can you make a poll, please? What? Any poll? just any poll, or are we feeling like certain question? What was the question on everyone's mind? Any poll. You know what? Fine. Fine. I'm gonna ask the question. I'm gonna ask the question right now. There we go. Answer away. So yeah, so then from this we'll get the number of particles, let's just call it big P, and then where is it? Hold on. What was the question? There we go, this. So then, A, how many moles of boron are present in 20 grams of borax? We have an amount, so basically now all we need to do is take P and divide it by Avogadro's number, and we'll get our solution. And when it comes to B, how many grams of boron are... Oh no, this is just boron. Oh yeah, so this will still apply, but when it comes to boron, we basically would need to take the Y and divide it by the B, so the atomic mass of boron. So this will still... Wait, no, this and then P times... P divided by N times 4 will give us the answer. And right here is just atomic mass of the whole molecule divided by boron. Let's see if I'm correct. So the formula with the molecular weight is... So this is our Y of U is 201. So 20 grams of borax contains 20 grams divided by 20... Oh, they went the other way. They converted this to grams. Okay, cool. No, you really threw my wrench in the world because you went the exact other way. That's annoying. Okay, so they got this in grams already. So the molecular weight is... Oh, because you got the of each and every single one in grams already. I don't want to do unit conversion this much. No. This is basically... I am awful with computations. That's why I like computers. They do it for me. They're amazing. I like calculations. I don't like computations. This is... I don't like moles. Did I mention that already? How is the poll doing? Oh, it's 50-50. It's not, it's a constant. I'm glad we all agree that mole is not a unit, only it's a constant. I am so glad we all agree. I am so glad we all agree. Hold on. Is it still... There we go. Yeah. How many atoms of magnesium will there be in 1 gram of chlorophyll? The plant photosynthetic pigment chlorophyll contains 2.68. This is... Where's everyone? Oh yeah, I think I mentioned last stream. Normally these live streams don't get as many watchers. The mole scared them off. Alright, this is volume occupied by 1 mole of pure substance. Okay, so makes sense. We have molar mass, so basically mass per... What really pisses me off about this is that we could have just made mole equal to 1 atom. Alright? Mole could have been just 1 atom. What's mole? Tilly, I am so glad you asked. It's... What's really annoying is that we could have made mole equal to just 1 atom. Just one. 1 molecule. Yeah, to be fair, it would be... Then it would be completely meaningless, because, you know, right now it's... As I often mention, it's not really a unit, it's a constant. Then if you take away the constant, it will be completely meaningless, but the point is... Then all of this would be so much easier, because you would have 1 gram... I mean, not gram, mass per molecule, basically. Which makes so much more sense than the mass per mole of molecules. I'm fine, I'm having fun, and this is fun. And then molar volume, which is basically volume per molecule. Great. This is volume occupied by 1 mole of pure substance. Of course, because it's, you know, it's molar volume depends on density of a substance, and light density varies with temperature and material expansion. Yeah, cool. Okay, it's fine. It's fine. Atoms in the periodic table. Sick. We're getting sick. Neat. Since we all know what moles are, I am not going to spend too much time on it because this live stream is really close to ending up just as like a 2-hour long rant of just why mole isn't a unit. But it's fine, it's fine. Quanta, new view on the world, let's go. Sounds like a lovely chapter. It wouldn't be actually the first time. It wouldn't even be a first live stream in which I would just spend an hour rambling all about moles. Okay. Classical physics, banal experience, award Pacific as a reward. Limits of classical physics. Yep, we've been over this in quantum mechanics. We already know what heat is. Quantum revolution. Nothing all that interesting. Gangster's female companion. Precisely. Argument would produce a formula that accurately describes the radiation spectrum of a perfect radiator, which is known as black body. Photoelectric effect, which I made a video about, and matter energy unified. Yes, yes, yes. Neat. E equals mc squared. Everyone's below it. Okay, this is just quantum mechanics, and fortunately, I've made multiple videos about quantum mechanics at this point, and we've done multiple research live streams, so we can fortunately skip over these. What is photoelectric effect? I have an entire animation dedicated just to the photoelectric. Okay, this is festive. We've just look how look, we're going that crazy. We're already on the 4th subchapter. This is great, and that's just because and this is also more quantum mechanics. Bohr atom. Oh, this is cool actually. Okay, Bohr atom is kind of neat, so we're gonna slow down for this. Most of an atom, yeah. And basically, then we have multiple models for describing how atoms work. And how long is this? Okay, yeah, let's go for it. Let's go. Finally, some new info. Bohr atom. This is gonna be fun. Let me just. Oh, the Bohr atom. Yeah, let's go for it. Alrighty. You already got your quantum Boy Scout badge. Precisely. I already got all the internet clout for knowing that, or, you know, knowing about them lambdas. Our goal in this unit is to help you understand how the arrangement of the periodic table of the elements must follow as a necessary consequence of the fundamental laws of quantum behavior of matter. The modern theory of the atom makes full use of the wave-particle duality of matter. In order to develop and present this theory in a comprehensive way, we would require a number of mathematical tools that lie beyond the scope of this course. We will therefore present the theory in a semi-qualitative matter, emphasizing its result and their applications rather than its derivation. Didn't we just go over like 3 different quantum mechanics chapters? Yeah, whatever. Models are widely employed science, yes. So models basically because of quantum mechanics. That's basically the reason. Once again, if anyone would like some more info, I've made an entire video about this. The demonstration by Thomson in 1867 that all atoms contain units of negative electric charge led to the first science-based model of the atom, which envisaged the electrons being spread out uniformly throughout the spherical volume of the atom. Ernest Rutherford, the New Zealander who started out as Thomson's student at Cambridge, distrusted this plum pudding model, as he called it, water roast, and soon put it to rest. Rutherford's famous alpha-ray bombardment experiment, carried out in 1909, by his student Hans Geiger and Ernst Madsen, showed that nearly all the mass of an atom is concentrated in an extremely small and thus extremely dense body called the nucleus, right in the center. This led him to suggest that the planetary model of the atom, in which the electrons revolve in orbit around the nucleus sun. Okay, so we have the nucleus, we have the electrons, and then we skip over all the other things and go for the Bohr model. More question is hurting me. What do you mean it's hurting you? It's a valid question. It's a valid question. Oh, there we go. 75% of people agree that's a constant. I am so glad you all agree. 80%. Oh, that's great. That is great. Fantastic. All right. So, Niels Bohr was a brilliant Danish physicist. We went over them all in like 10 minutes. It was a blast. It was so fun. Brilliant Danish physicist who came to dominate the world of atomic and nuclear physics during the first half of the 20th century. Bohr suggested that the planetary model could be safe if one new assumption were made. Certain special states of motion, in quotes, of the electron corresponding to different orbital radii would not result in radiation and could therefore persist indefinitely without the electron falling into the nucleus. Hi Hungary, make it so make it stay on track. Would not radiation could therefore specifically Bohr postulated that the angular momentum of the electron, MVR, the mass and angular velocity of the electron and in orbit of the radius r, is restricted to values that are integral multiples of h divided by 2 pi. The radius of one of these allowed Bohr orbits is given by... That's really cool. Okay, so let's note down everything we can. So, we have... Goody, this is gonna be festive. Let's insert the equation. R is equal to NH 2 pi mu. So, the angular momentum of the electron is restricted to values that are integral multiples of... Okay, so first of all, let's make this bigger. Second of all, let's note down MVR. Why is my OBS disconnecting again? You mind, OBS? I'm kind of busy. So MVR is equal to KH divided by 2 pi, where M is mass, then V is the angular velocity, then we have... Oh wait, it's an integral multiple means what I think it means, right? It's just a multiple based on an integer. I just want to double check before we go in. R is equal to radius. Then we'll have, because otherwise I didn't know that, K, which is just an integer, and then H line constant, and pi is just pi. Alright. There we go. And then we have the radius of one of these allowed Bohr orbits is given by this, because we just... Why is that U? Hold on. Why is that U? This would make sense if this was a V. Hold on. Why is that a U? I think that's a mistake, honestly. I think that's a typo. I think that should be a V, because then it would make sense. if this was a v, then this is just this equation rearranged, right? We divide both sides by mv, and we end up with r is equal to k times h divided by 2 pi mv. So I think that was supposed to be a v. I think it should be like this. Then we should just, you know, there we go. So we can get the radius, basically. My point is, the most revolutionary aspect of the assumption was its use of the variable integer n, or k as I noted down because I'm cool. This was the first application of the concept of quantum number to matter. Oh, it's a quantum number. Well, then it should be an n. Whoops, never mind. I wanted to be cool. I wanted to just come up with it all on my own, but no, this is just supposed to be an n. This is, whoops, my bad. Alright. Larger value of and larger the radius of the electron orbit and the greater the potential energy of the electron. Makes sense. Do we have an equation of potential energy? Hi there everyone, by the way. They're all just saying hi and I feel excluded. As the electron moves the orbit of increasing radius, it does so in opposition to the restoring force due to positive nucleus, and its potential energy is thereby raised. This is entirely analogous to the increase in potential energy that occurs when any mechanical system moves against a resulting force, as for example in the rubber band stretch. Yeah. I think this is what I'm looking for, right? Discrete energy states. So, and the energy of the atom is quantized. Bohr noted that this quantization nicely explained the observed emission spectrum of the hydrogen atom. The electron is normally in its smallest allowed orbit, corresponding to n equals 1. Upon excitation in an electrical discharge by ultraviolet light, the atom absorbs energy and the electron gets promoted to higher quantum levels. These high excited states of the atom are unstable, so after a very short time, around 10 to the -9 seconds, or 10 micro, right? Wait, milli... nanoseconds. 1 nanosecond, I think. Oh my goodness! Hi there! Wait, Crimpy, right? You have a... Why do you have this emoji as your... It's always so confusing. Boom. There we go. I'm back. Sorry, just had to. Alright. Bro. Got some views actually. Thank you. Yeah, we're moving up in the world. I'm almost getting paid $0.01 a day. We're really in the money now. The grind is real. That is quite nicely explained the observed emission spectrum of the hydrogen atom. The electron is normally smallest allowed orbit. Yes, the electron falls into the lower orbit and finally into the innermost one, which corresponds to the atom's ground state. The energy lost on each jump is given off as a photon, and the frequency of this light provides a direct experimental measure of the difference in energy states. According to Planck-Einstein relationship, E is equal to hv. Yes, okay, cool. Bound states. Oh, we're getting into real fun bits. I don't know what views happened, but no, the addition to quantum mechanics views. We're still talking about that one. Vibration, standing waves, and bound states, right? Bohr's theory worked. It completely explained the observed spectrum of the hydrogen atom, and this triumph would later win him a Nobel Prize. Good for Bohr. The main weakness of the theory, as Bohr himself was the first to admit, is that it could offer no good explanation of why these special orbits immunize the electron from radiating its energy away. Its only justification for the proposal, other than it seemed to work, comes from its anarchism and behavior of vibrating mechanical system. Yeah, it just works, alright? It just works. Trust the guy. He won a Nobel Prize, so I would trust him. Nobel Prize, that's a good credential. In order to produce a tone when plugged, the guitar string must be fixed at each end. That is, it must be bound system and must be under some tension. Only under these conditions will a transverse disturbance be countered by zoning force, the string's tension, so as to set up a sustained vibration. Having the string tied down at both ends places a very important boundary condition on the motion. The only allowed modes of vibration are those whose wavelengths produce zero displacement at the bound ends of a string. If the string breaks or becomes unattached at one end, it becomes silent. Makes sense. Yes, you only are allowed to have... You can only have these. Okay. Okay, it's a good explanation, I suppose. So, like, you can't have... Hold on, let me bring on my paint again. So when it comes to the guitar, like, if you have a string which is tied in between these 2 points, right? You can displace it in a way so that it would have this sort of wave on it, right? But you can't displace it in a way so that it would have this sort of wave on it, because it has to be bound to this point. Okay, makes sense, I suppose. And then, you know, this would be an integer. Then you can basically this, yeah, so like this, right? All of these would be based on integers, because anything in between, any sort of rational number in between these integers, or irrational, anything in between those integers would result in this not being bound to the certain node. Okay. Maximum displacement, high quantum numbers, high energies, the vibrational states of the string acknowledge the sense that an integral number of round nodes must be present. Right. Standing waves in hydrogen atom. We're getting some serious progress now today, that's festive. Alright. Alrighty then. Your fractional crystallization nodes are something else. Thank you. That's actually the scientific definition for fractional crystallization. You can check yourself in Britannica if you want. That's precisely what they know down. That's the only sentence you'll find. That's it, because it's a perfect explanation already. The analogy with the atom can be seen by imagining... Hold on, I spoke 7 different commas in that sentence. The analogy with the atom can be seen by imagining a guitar string that has been closed into a circle. The circle is an electron orbit, and the boundary condition is that waves must not interfere with themselves along the circle. This is a fantastic explanation. This condition can only be met if the circumference of an orbit can exactly accommodate an integral number of wavelengths, and thus only certain discrete orbital radii and energies are allowed, as depicted in 2 diagrams below. Precisely, yes. So, for example, if you have this wave like this, if you increase the wavelength by just a little bit more, or no radius. So if you increase the radius, then this would no longer be continuous. You have to at some point just jump up and continue on. That's great. That's it. I love this explanation. Alright. Unbound states. If a guitar string is plucked so harshly that it breaks, the restraining force and boundary conditions that restricted its motion to a few discrete harmonically rated frequencies are suddenly absent. With no constraint in its movement, the string mechanical energy is dissipated in a random way without musical effect. In the same way the atom absorbs so much energy, the electron is no longer bound to the nucleus, then the energy states of the atom are no longer quantized. Instead of the line spectrum associated with discrete energy jumps, the spectrum degenerates into a continuum in which all possible electron energies are allowed. The energy at which the ionization continuum of an atom begins is easily observed spectroscopically and serves as a simple method of experimentally measuring the energy with which the atom is bound to the electron. Electron is bound to the atom. Whoops. Make it. I have a homework to do where I ask someone who studied the career I want to study. So you just say hi to the camera and I'm answer. Okay. I am answering Appleman's question. You're welcome. Cut that if you want. Well, you can ask me questions, I guess. It is a live stream, you know. Phenomenal. Alright. I make it, and I support this message. There, and music ended perfectly. It's a perfect place to cut. Anyhow, hydrogen, the simplest atom, can also has the simplest line spectrum. Line spectrum I briefly introduced in the previous chapter. I skipped over this chapter. The hydrogen spectrum was first to be observed by this person in the 1860s. Why are the three ends? That's not... No, there's no way. It has to be another typo, right? I knew it! There were only two ends there. A German high school teacher discovered a simple mathematical formula that related the wavelengths of the various lines that are observable, visible near UV parts of the spectrum. Survives now known as a Balmer series. Okay. Alright. I don't really get the significance of this chapter yet. Like, it's all really interesting, but it seems interesting for quantum mechanical reasons. And I know for a fact, because a couple of live streams ago we skipped over to learn how PNP transistors work and failed. We skipped over forward, and we know that we'll be talking in terms of chemistry. So I don't really... I know that, you know, quantum mechanics is important. Okay, this actually seems important too. Alright, so if a hydrogen atom absorbs radiation whose energy corresponds to the difference between that of n is equal to 1 and some higher value of n, the atom is said to be in an excited state. Excited states are unstable and quickly decay to the ground state, but not always in a single step. For example, if an electron is initially promoted to the n3 state, it can decay either to the ground state or to the n equals 2 state, which then decays into n equals 1 state. Thus, this single n1 to 3 excitation can result in three emission lines depicted in the diagram above, corresponding to n3 to n1, n3 to n2, and n2 to n1. Okay. If instead enough energy is supplied the atom to completely remove the electron, we end up with a hydrogen ion and an electron. When these two particles recombine, the electron can initially find itself in a state corresponding to any value of n, leading to the emission of many lines. And what now? Everyone spawned going to HTTPS console to make it W. Sorry, that ring on yourself. HTTPS console to make it W. Sorry, that ring on this man. Charity ain't got such a pie for yourself. Right now, we're calling my charity DBS lines. Link on the screen on the description. HTTPS console to make it W. Sorry, that ring on this man. Charity ain't got such a pie for yourself. Would recommend. Speaking of charity. Alright, if instead. Oh, this is tough. This is actually tough. Okay. It's fun, but it is fun. It is fun. But this is tough too. It's fine. I'm honestly kind of done with quantum mechanics at this point. I'm kind of sick of it, will not lie. How many quantum mechanics research live streams have we done? Too many. Too many plus one. Alright. If instead enough energy is supplied to the atom to completely remove the electron, we end up with a hydrogen ion and an electron. Makes sense, that's what ions are. When these two particles recombine, so hydrogen missing an electron, plus equals missing an electron, because electrons have negative charge, plus electron, which has a minus because it has a negative charge, you get back hydrogen. The electron can initially find itself in a state corresponding to any value of n, leading to the emission of many lines. So initially it can end up on any shell, right? Hold on, so if you take a hydrogen ion and give it an electron, it can initially be on any shell, but then it collapses to the first one. Make it has a spy to quantum mechanics after this video views polarization. No, I don't have a spite, it's just that I've done too many videos about quantum mechanics. That's just it. Now listen, I'm just done with my quantum mechanics arc, and now we are getting into my chemistry arc. Can't really follow on quantum mechanics. I'm bad with chemistry and physics simultaneously. Oh, don't worry, if you don't like chemistry or physics, then quantum mechanics is for you, because it's actually neither. Listen, do you like waves? If you do, quantum mechanics is for you. Quantum mechanics is just waves, and that's it. It's just math with waves. There's nothing else in it. Like, technically, yes, you do have, like, some equations which are based on classical mechanics, but those really are irrelevant. Like, for example, in quantum mechanics, you have momentum, which is just related to the wavelength. You have momentum, which you can apply to things which have no mass. And that's just fun. Chemistry arc. Chemistry arc. I just quantum mechanics arc, but bigger. Maybe, I don't know. I don't know how long the chemistry arc will last. I also want to get into my electricity arc, for which we're doing actually this, chemistry and electricity. Look how productive we are. Two at once. Emission and absorption spectra. Oh, festive. Hold on. Wait, we're not done with this. The lines of the hydrogen spectrum can be organized in different series according to value n at which the emission terminates, which absorption originates. The first few series are named after discoverers. The first observed Balmer series, which lies mostly in the visible region of the spectrum. Okay, so alright, seems simple enough. Massless things sure are awesome. There aren't the things. It's waves. It's always just waves. That's always what they are. It makes sense that they have no mass. It's just, you know, if you have no mass, quit acting like a particle. Am I right? Relatable. Emission and absorption spectra. The line emission spectra we have. Go back. The line emission spectra we have been discussing are produced when electrons which had previously been excited to values of n greater than 1 fall back to n equals 1 ground state, either directly or by way of intermediate end states. If light from a continuous source, a hot body such as a star, passes through an atmosphere of hydrogen, such as stars' outer atmosphere, those wavelengths that correspond to the allowed transition are absorbed and appear as dark lines superimposed on the continuous spectrum. Okay. Alright. Oh, that's it. Now onto the quantum atom. And then electron configurations, which I love. I love electron configurations. Probably make it even if we are close to being massless. What was that? Sounds like a threat. What's all this mumbo jumbo? We're talking about quantum again. I'm trying. I wanted to stop talking about quantum stuff. I just wanted to move on to chemistry. Why are we going back to quantum? Okay. About 10 years after. Oh, do we really have to? I don't care about history. Okay, so we have kinetic energy. So this is just momentum squared minus. Like the quanta and stuff? I don't know, honestly. I don't. The psi functions? Come on! It's the one thing. Can we move on? We've already been over this in so many other live streams. We've already been over this. I don't care. Quantum is the way. I'm sick of quantum stuff. Physical significance of n. Okay, this could be this. Nothing down actually. Nope, not Johann Balmer. I meant this. E is equal to -4 pi squared e to the fourth sick m Planck squared n squared. Or in other words, the higher the shell, the lower the energy of the shell, which makes sense. Wait, no. No, it does not. Potential energy of an electron, because then the lowest shell will have the highest potential energy. I'm sorry, what now? Negative! There, I missed. Okay, I missed that one. Okay, yeah, so that makes sense. The lowest shell has the lowest potential energy. Okay, cool. The negative sign ensures that potential energy is always negative. Notice that this energy is inversely proportional to the square of n, so that the energy rises towards 0 as n becomes very large, but it can never exceed 0. Okay, makes sense, sick. Angular momentum of quantum number. Jeez, can we please stop? Oh, what more quantum mechanics is there? Okay, that's it. Okay, we're almost done. I wanna be done. Use the Fermi. Wait, Fermi. I'm pretty certain Fermi paradox is not quantum. Yeah, I feel like. Yeah, I'm pretty certain. I'm kind of certain that Fermi paradox is about aliens. I don't think it's about quantum stuff. So this is good to call a real mechanic instead. Okay, the election wave functions are derived from the Schrödinger's theory. Let's try again. The electron wave functions that are derived from Schrödinger's theory are characterized by several quantum numbers. The first one, n, describes the normal behavior of the probability distribution of the electron and correlates with potential energy and average distance from the nucleus, as we just described, yes. The theory also predicts that orbitals having the same value of n can differ in shape and in their orientation in space. The quantum number L, known as the angular momentum quantum number, describes the shape of the orbital. Precisely, L determines the number of angular nodes, that is, the number of regions of zero probability encountered in a 360 degrees rotation around the center. Is that really required to understanding how PNP transistors work? Make it, who are you voting for in November? Not American, but still. I am voting for Bernie Sanders. It's not lazy. Y'all have... this is gonna be fun. This is gonna be fun because, like... No matter what, it's gonna be... no matter who Americans choose, that dude's economy. Yeah, it's chaos, I'm all for it. It's really funny actually, because no matter who Americans choose, it's gonna be bad. Maybe except Bernie Sanders. Bernie Sanders actually seems like the most sane right now. So you have like, the only three major picks, as far as I'm aware, right? Donald Trump, Joe Biden, and Bernie Sanders. So you have a criminal, you have someone who's useless, and you have someone who is too socialist for America. He's asking for financial support. I feel like Bernie Sanders should just move to Europe. He would have allegedly accrued. Wait, you mean Donald? Wait, you mean that Donald Trump is not allegedly a criminal? No, hold on. Donald Trump is allegedly a criminal in some lawsuits. No longer, no. Donald Trump is not. No, no. Donald Trump is allegedly a criminal in some lawsuits. Which is so funny to me, in my opinion, because like, no matter you're in America are screwed, you don't have a single good pick. Laughs in European. Bernie Sanders probably considered the right wing in Europe. No, 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 no. I wouldn't go that far. Bernie Sanders would still be left wing in Europe. It's just that, you know, in Europe you have a lot more left wing countries. Netherlands, France, all the other ones. You know, all of them. Like, I feel like Bernie Sanders could do really well in the Netherlands, in my opinion. France, I don't know. I don't know about France. In France, they're still going to the whole... Or maybe France would be even better, because in France, they're like moving into the left. But yeah, this is gonna be... You know what? You know what catharsis is? Do any of you know what catharsis is? I'm just making fun of how different the US and Europe are in terms of what's left and right. That is true. That is just way different. But do you all perchance would happen to know what catharsis is? It's basically where you experience or find something really negative, so negative that makes you feel positive. So for example, when you watch a scary movie, or when you watch a sad movie, or when you experience something sad that doesn't actually affect you, then you realize, oh my goodness, my life is actually so amazing. That's basically what's gonna happen to all of Europe. Because America is gonna have a huge problem no matter who they pick. And we're just gonna be chilling here like, oh, thank goodness that's not us. As well, consider the limit of principal numbers. L can be not greater than n-1. This means that for n equals 1, L can only have the single value 0, which corresponds to a spherical orbital. For spherical reasons, the orbital corresponding different values of L are designable letters starting with yes. The function relationship is given... I'm sorry, what now? Well, that's an equation. Hi, the Kuant. Hi. Ali, who will you be voting? Spill the beans. Please don't, actually. It's a very bad idea to talk online about who you're gonna be voting for. I don't even want to understand what you're researching. It's okay. Right now, I get it. Because we're in the... I had my name. No. I was just throwing you under the bus, don't worry. It seems smart, but that's only because we're in the quantum mechanics chapter. And quantum mechanics is famous for the awful notation. Z is nuclear charge of atom, which of course is unit of hydrogen. Yeah, cool. So we can skip over this for now. There we go. What are Canadian politics like? That's a good question. Wait, I don't think Canada has it. Wait, I don't think Canada has a government, do they? I feel like... No, Canada doesn't have a government. In Canada, they just sit there, chilling, right? Don't they? I feel like in Canada, there's just snow. They don't have a government. We don't have a government? Yeah, right? No? You have Toronto. And that's it. Canada is like USA, but better. Canada is like... America is like... US, can I get an amen for our troops? Except... mild. Canada is like a mild version of the US. Okay, about Junior America. Since no one's there, you can just do whatever you want. Precisely. You know what? It's still kind of weird in my opinion that Americans didn't like conquer Canada. They can just do it. For goodness sake, Americans have more guns, accounted for guns in their country than they have people. They have more guns than they have cars, okay? Like, and then oh no, we would never invade Canada, it'd be awful. Yeah, right, bunch of stuff. The Toronto mayor did a lot of crack, I know that too. Oh yeah, I remember that. Oh, that's true. That is true. Canada's America too. Rob Ford. Oh, I remember that guy. Oh yeah, Ford. The one who like publicly admitted to doing crack. That was a good mayor. Powerful mayor. Loved by everyone, certainly not. Didn't sell out stuff for political gain or something. One electron atoms. Atoms contain a single electron. Let us begin with atoms that contain only a single electron. What do you mean? Oh wait, this is electron configuration. Never mind, I know this. Right? Yeah. So we have shells, subshells. I think Canadians would politely ask people not to invade. Will the soldiers step aside cautiously? We almost didn't get a lot this year. We almost didn't get a lot this year. Powerful. Alright. That's the most Canadian of a sentence. I'm really sorry for asking you for considering not invading us. In total, in Montreal, we get around 2 or 3 meters. Oh, maybe that's why. Oh! It's the Eastern Europe defense. The Soviet defense. Just like, you want people to not invade your country? That's simple. Just snow. That's it. No one's gonna invade Canada. 3 meters of snow in it. Each has the ground state configuration one. That's meaning a single configuration. Yeah, cool. Important feature of a single electron atom is that the energy of an electron depends on principal common number and affecting the energy. All editors having given a value of n are degenerate. I'm sorry, what? Metric system detected. Oh yeah, that's true. We're not using freedom units. Water, first of all. That is true. That is true. Water might be important. Can you imagine? We're slowly but surely heading into a future in which Canada will be a global superpower because they have water. Cringe. How can we let that happen? We have to stop global warming. Because if we don't, Canada is gonna become a superpower. Especially with climate change and stuff, water will become more and more. Precisely what I'm saying, right? We need to stop global warming not to make the planet livable or something, only because Canada will gain more power the more global warming we cause, okay? Everyone, we need to be more eco, alright? Otherwise, those pesky Canadians... okay, everyone from America listening right now, do we all really wanna let Canadians win? I posted my... What, Ali, what did you... That looks... Oh, I didn't want to see that. Okay. No, we have oil. Yeah, but the more global warming you cause, the more powerful water becomes. Also, I'm pretty certain... Hold on. You know what? Let's check it. Or rather, hold on. There we go. What is the ratio? What is the ratio of when it comes to the usage? That's, yeah. USA! USA! It's over 50%! No, that's just imports. No, I'm looking for... Wait, is this the real graphic? Is this really 51%? This... Okay, this looks suspiciously like... It was just made so that politicians could claim that, like, most US oil is native. What's so hard about using seawater? Yeah, just a bit salty, so what? Just tasty. Province has a big express movement rising right now. We have most of that water, so... It's Canada who has the water. You make it. Hi there, Joshua. You've joined in at the perfect time. This is the time, the portion of the live stream in which we slowly move onto geopolitics. Fracking gonna solve the oil. Yeah, but like the problem is not the oil. The problem is that, you know, the more global warming we cause, the stronger the Canada gets. Do you really? Okay, Don, answer me. Do you really want Canadians to be in power? Are you ridiculous? You can't let that happen. I'm gonna drink all the oil. Has low calories, I'm just saying. Question for... What do you enjoy most about your career? Oh, fuck, I don't enjoy. Oh, that's... What do I enjoy about my career? Let's first answer that question. I mean, everything. Yeah. Do science. I like the fact that I can do science a lot. I can, that like, you know, I can basically do science. And that's what I like most, I think. How can you apply quantum to military technologies, bro? Listen, quantum isn't that great when it comes to weaponizing stuff. Quantum, like people, when people hear quantum, the word quantum, they always think of like atom bombs and stuff, but it's not, that's not what it is. It's easier to weaponize economics than it is to weaponize quantum, honestly. As someone who lives in Canada, I don't, so you better not wait. You don't what? Movies use quantum to explain everything because no one understands it, so they blame on that. Precisely. It's like, it's a drinking game, honestly. Take a shot every single time you hear the word ion. Ions, like things which are ionic, it's not a complex thing. Ion is just an atom with a different number of electrons, which is not crazy. Ions aren't these mysterious, magical elements which just give you superpowers. Ions are just atoms with more or less electrons. It's so boring. Who wants Canada to be in control? I said no. Oh, that is true. You know what? That's fair. That's gonna be our campaign. We need to stop global warming to keep Canadians out of power. Put that in the t-shirt. But would ion cubes from Subnautica war as a power source? That's the problem. It's so vague. Like, imagine... Okay, you know what ion cubes... Let me give you an analogy. Imagine if instead of ion cubes, these would be called molecule cubes. As in, you know, like... Just... molecule cubes. Imagine if they were called molecule cubes. Like, I mean, yeah, it could be a power source, depending on the molecule. And that's the problem, like, ion cube is such a vague term. Like, ion cubes or something. Precisely, right? It could be iron, which is iron, I love the way I pronounce that. Palladium ions, it could be hydrogen ions, for all we know. Didn't Kanye West, for election, promise to lead US to, quote, Wakanda way? What a time to be alive! Wait, isn't he called Ye West? I'm pretty sure he's called Ye, isn't he? Ye West. Where's he stuck? Ye! There's a lot of controversies in the mood because how are we gonna make nukes with those cubes? A block of electrons as ions. Ammo could displace electrons. No, it wouldn't be a block of I mean, I guess you... Hold on. I mean, I guess if you have ions, if you like overcharge an atom with electrons, I guess then you do have a lot of spare like if you find a way to bind atoms oversaturated with electrons, like if you get some sort of really heavy atom, right, something really heavy, then you could in theory jam it with electrons, and then if you found like up to the next noble gas configuration, and then if this would make like a stable something like a ionic bond, I suppose, then this is alien technology, so it could mean literally anything. But the point, I mean, I guess maybe that's what they meant, as in ions, as in having excess electrons, and so these electrons could be used. But it's so vague and it's so sci-fi, it could mean anything. Too much on realism, but they're green and shiny, that's fair. Thorium, wait, wait, what's thorium? What's something called thorium? Thorium OS. Well, that's not what I'm looking for. Thorium.rocks. 90? Thorium Rocks that's a great website. Uranium, then silver in the crust. I mean, oh yeah, thorium. I remember now. Oh yeah, thorium was just the better version of uranium. I remember. Okay, now I remember. Yeah. All right. The thing is, I don't like atomic bombs. They're so primitive. Like, imagine there's so many cool things you can do with radiation and chain reactions, and people fucking, the first thing they did is like, oh, kablooey, we see world destruction. Childish. Most important feature of a single electron is that I don't like bombs, atomic bombs. I really don't like them. And I especially don't like how many there are out there. They're trying to make reactors. I don't think they're trying. I think they already made a lot. And I think thorium reactors are a thing. I think they do. Someone watch Salmonella. I'd recommend Salmonella. I don't like Salmonella. Not because I really don't. Not because like of quality of videos, only because Salmonella is getting tens of millions of views, and you have no idea how much money that is. I'm jealous. Can you make a fusion reactor for a project? I mean, define fusion reactor. Like, I could make fusion for a project. It wouldn't be easy. It wouldn't be cheap. It would be really expensive. I don't. If you think of a reactor as something that generates more energy, like a net positive, then no, I don't think so. I don't think I could make that. Didn't a kid in the UK make nuclear reactor? A lot of people made nuclear reactors for foundries. Wasn't like Atomic Scout, I think they were called. They had a name. So catchy. Alright. It takes 1312 kilojoules of energy to remove the electron from a mole of a hydrogen. From a mole of hydrogen atoms. Moles. Okay, it's fine. What might we expect this value to be for helium? Helium contains 2 electrons, but its nucleus contains 2 protons. Each electron sees both protons, so we might expect the electrons of helium would bond twice as strongly as the electron of hydrogens, but that's obviously not gonna happen because its quantum mechanics always has to be more complex, am I right? The ionization energy of helium should therefore be twice 1312 kilojoules per mole or 1612 kilojoules per mole. However, if one looks at the spectrum of helium, the continuum is seen to begin at a wavelength corresponding to the ionization energy, 90% of predicted value, because obviously it's more complex. Hold on, I'm right now wondering something. I'm gonna buy uranium glass and Geiger counter. How could you make nuclear reactor without nuclear fuel and stuff? You don't need nuclear fuel to make nuclear reactor. You just, well, as in, you don't need something, you don't need enriched uranium. No, wait. You don't need the military grade power, military grade nuclear fuel to make a reactor. You just need nuclear fuel. So he did do it with nuclear fuel. There's not the kind of nuclear fuel you're thinking of. I'm pretty certain it was smoke detectors, right? Radiation isn't as uncommon as everyone thinks. Making a medieval forge with some friends. I was just scrubbing on some maybe I shouldn't judge nuclear reactor people. Don't you need uranium stuff? What do you mean by uranium and stuff? Once again, so vague. I mean, yeah, but it's not like... But that forge is really cool. That is really cool. Damn. Men only want one thing, and it's just to have a workshop with a forge and like high-tech tools. How expensive would it be to buy a lab, actually? Can you wait? Hold on. Can you make a laboratory? Wait, can you turn a housing unit into a laboratory? Pretty recently, like, how is kids gonna find the uranium? Buy it online? That's how. Hold on, Amazon isn't working. Give me a second, I'll be right back, just need to... Okay, I am back, there we go, just had to quickly run over to a different country. So, the thing is, telling me English kid bought uranium online, made nuclear reactor on... I mean, look at this. You can buy, for example, copper bar, hold on. That's gallium. That's preset in pure element sample kit periodic table. Does that have uranium? No idea. But you can buy, for example, something like this and you can extract uranium from it if you want. Technically. I don't buy that cold BS. It's not impossible. It's not alchemy. I don't get what's so weird about this. Like, you don't have to buy literal uranium. You just need to buy something which has uranium. And that's not honestly that difficult. Like, for example, uranium watch, which is a thing. Is there a single one like a uranium? You know what I'm thinking of, right? You have certain watches which have like some things use uranium to basically like glow in the dark and stuff. Then you need like tech and stuff. What kind of tech? What kind of tech you're thinking of? It's not science fiction. Uranium glass like 2%. 2% is already crazy high. Radium and tritium for waters. Yeah, but you can still make it reactor without a triad now. It's not science fiction. For example, you... Okay, no, I'm gonna assume that Noel is right in this. So, if uranium glass is 2%, that means a kilogram of uranium glass could give you, in theory, 200 grams of uranium. No, wait, 20 grams of uranium. 20 grams. If you buy 10 kilograms, that's already 1/5 of a kilogram of uranium. Does it sound weird? I might have switched to... Hold on, let me just be right back. Just need to go back to Germany. Alright, there we go. We're back. Just need... There we go. I'm back. Hi everyone, welcome back. I'm from Germany. Germany make it. I don't know, uranium's... I like uranium, but not for the same reason as most people do. I like uranium because... Most people like... I don't like the reason for why most people like uranium. Like, most people like uranium just because it's dangerous, which, I mean... It's dangerous. I just don't like what... Like... You get what I mean. You know what I mean. Anyhow. I like uranium because it's heavy. You have uranium, then where's neptunium? You have... oh wait, polio? I don't know. Wait, it was radium and then there was the Polish one. Have you seen uranium crystals? No, I have not. Let's see. Crystals are really cool. I really like crystals. Oh, that's neat. I really like crystals in general. Crystals are so sick. Yeah, it's a heavy element. Crystals in general are sick. Bismuth is nice. This is pretty difficult one. Why electrons usually bound less tightly than plus 2 charge with larger suspect? The answer is that there is another effect to consider: the repulsion between two electrons. Makes sense. Major fraction in both the spectral and chemical behavior of element heavier than hydrogen. Particular break the degeneracy. Split the energies of orbitals. Okay, so below shows how the energies of s and p orbitals of different principal quantum numbers get split as a result of electron-electron repulsion. Notice the contrast with similar diagram for one electron atoms near the top of this page. The fact that electrons preferably fill lowest energy empty orbitals is the basic rule. Is the basis for the rules determining the electron configuration of elements periodic table. I'm looking for something new. Okay. Why didn't they make swords out of uranium back in the Middle Ages? Why would they? I have a better question. Why would they make swords out of uranium? Is uranium actually green though? I think so, right? Green glow? I mean, we've just seen the crystals. Bone glass can be green. Yeah, so it's great about green glow. I just don't get why people would make swords. Like, even in current age. Why make swords out of uranium? They could have made some real serious blades, bro. But like, why would you make a sword out of uranium and not steel? What's the advantage? It's more difficult to make. You're gonna poison yourself, so you know. Gotta be worth it. Cut through Vikings and shit. Yeah, but you can do the same thing with steel. Like, steel swords also can cut through stuff. Making uranium so for dust and rat damage, obviously. Hell, but what if you're fighting against a ghoul? If you're fighting against a ghoul, they're just gonna heal themselves back up? It's gonna heal them. What then? See, the double-edged sword, pun intended. But we're gonna start with gardening tools and stuff, practicing, and then we're gonna try to make knives into the blade. That's cool. With uranium sword, you could kill an entire Viking legion. You can do the same thing with a steel one! What's the advantage? That's like arguing that, I don't know. I didn't even know what to compare it to. That's like arguing why... Oh, damn it, it's really hard to compare it to anything, honestly. Ghoul dead inside can connect... I don't get that reference. Yeah, but uranium is more bad. One of my friends already sharpens knives and stuff from time to time, so we can sort. Well, I imagine that's gonna be so cool. Quant, be sure to send pictures. That's gonna be great. Cobbled sword. I'm actually. What would be a cool material for a sword? I just don't get the idea of uranium. Uranium sword sounds like a. It's gonna be in a long time. So what? I don't care. Still, send pictures. What about the diamond sword? Again, the thing is, Don, you're trying to... The main issue is that all of these give you, like, marginal, and I do mean marginal upgrades for a high price. And I don't just mean money, I mean, could cut through everything. No, it couldn't. Okay, so here's the thing. How should I put this? Diamonds... It's not really a feature of diamonds that they can cut through anything. They are tough. Wait, are they tough or are they... Ah, they had one of these... I don't even remember the feature. They have some sort of feature, right? But it's not a matter of resistance, toughness, or whatever that makes stuff able to cut other things. So you have to remember that when it comes to the diamond sword, as you amazingly put it, you would need to sharpen it somehow. And the thing is, would a sharp diamond sword really be better than a sharp steel one? From I didn't believe cobalt is real. So Terraria is a Terraria. Yeah, because it is. It's not real. It's they're trying to trick you actually. This is just propaganda. This doesn't exist. Netherite sword. Hell yeah. You know, like, why would you ever need a diamond sword when you could just take an iron one and apply a sharpness 5 book? Precisely. Noel gets it. We should use quantum sharpening. I feel like I'm talking with like a movie scientist, honestly. Like these are just pop culture. This is pop culture science. I mean, the blade would not get would not chip or get dull. You wanna know something? Okay. You've seen Oppenheimer? No, I haven't. I already know the story, so I know the spoilers already. I kind of am familiar with Oppenheimer, so I know the spoilers. Hold on, let me show you something. Let me show you... The movie was tight. Yeah, as I mentioned, I already know the story, so... Let me show you something actually cool about diamonds. You all ready? This. Now this is a cool diamond.
Hello everyone, Harry here. Welcome to Scrap Science.
Would recommend watching this video if you wanna see some actual cool diamonds. This bug, because YouTube is gonna blast the music in a second. Would recommend Scrap Science on YouTube. Ionized quantum battery to sharpen your Neptunium sword. Ah, precisely. And then you have to use the tunneling and the bending of space-time in order to... I don't know. Use entanglement with a wave function in order to apply the Schrodinger's equation Precisely. Oppenheimer is so good, like the cinematics and music was really good. Yeah, but I already know the story. Like, how am I gonna watch the movie knowing that Japan is gonna get bombed? I already know that. You know, Superman is so strong he would crush charcoal so hard into diamonds. Wait, can charcoal... Is charcoal is coal, right? It's... Wait, because that's... Wait. Can you... Hold on, can you make diamonds out of charcoal? Because charcoal... Charcoal is just... How pure is charcoal? Hold on, I'm having a make it thinking moment. When it comes to... Wouldn't it be... I would recommend the Calamity mod for your music, as I think some of the themes fit the music used in your streams and vids. The music I use in my streams and vids, you mean the music made by https://youtube.com/add_sodakcmusic. Oh yeah, we're also making homemade charcoal for the forge. That is so cool. That is so cool. That is Quant. You are damn. You are living every man's dream. Right now, you're living every man's dream. I find it funny that your job is just to bend stuff. Damn, now I want to make a forge, but I don't have any space for it. How expensive are plots of land in Europe? I wanna buy a plot of land and turn it into a lab. Is that really too much to ask? Stop playing with Ethereum, making everything harder and better. Like PC can no longer handle with mods. And once using them, we can't go back. I think Kuan deserves crab roll. I mean, Kuan is I don't know. I'm too jealous, honestly. Having a forge. Can you imagine having a forge? We'll get there one day, boys. We'll get there one day. I need money. You know what? Yeah, we're gonna end the stream. That's it. Kuan motivated me. I need to make videos to get money to make a lab. I have a clear goal in life. I need a laboratory. Because right now I have a makeshift lab, but the makeshift lab is not good enough for another lab. Charcoal beyond piles takes too much place, using barrels and special techniques. Hold on, okay, I'm holding. How can quantum make us rich? And unfortunately, there isn't much money to burn in the science. Mad scientist transition on the way. I need money. Okay, I have a plan. I just need money. We checked the prices to make a lab. I checked that before last year. How? Oh, wait, no, because hold on. Like when it comes to laboratories, right? Laboratories to buy in Netherlands. I just really like Netherlands, honestly. Has biotech companies. No, I'm just looking for. Wait. Where to buy laboratories? Or maybe not laboratories, only just a plot of land, right? Hold on. Plot of land to buy in. And then you can just build a lab. Do some chemistry. You can make a surprisingly large amount of stuff at $400. Yeah, precisely. Chemistry is... I mean, equipment is expensive. Equipment is really expensive, but the things itself are not. Once you buy the equipment, you can make almost anything for $300. When are you gonna do your first collab with another YouTuber? Ooh, I'm so glad you asked. Wait. Honestly? Okay, other side, you want a real answer. You want an honest, real answer on when I'm gonna do it? 3 to 7 days. And that's not what I'm gonna start planning. 3 to 7 days, that's when it's gonna be up on YouTube. I should check to do that, but my student asked couldn't. Yeah, I get you, can't. What will the vid be about? You will see. Why deleting, retracting the message? Yes. Other side, come on. Oh, now you don't want people to know that you actually wanted to know, huh? I see how this. Is it one of the channels we recommended? You will see. You will all see soon enough. Unless you want to see right now, in which case my Patreon. If you go to my Patreon, you will see right now. And you will also see a preview of the video, because I already finished a preview of the video, which is up on Patreon. Subtle ad. I need money, okay? I want to buy an ab. Bro's doing collab with Mr. Beast. Nah, I don't know. I'm Mr. Beast one, but damn, I didn't see it. Did you really not? Oh, you did. You did see. You did see. You just didn't know. You know what? Okay, I'm gonna tell Qant. I'm gonna tell Qant because Qant right now on Patreon channel. I'm gonna tell you. The you want to play into Flyme? Listen, VTuber is talking in keyboard sounds. It's a language. That's really fucking cool, right? That's really cool. I'm really excited for it. And the best part is, this person, because this person, someone made that a clip that was hilarious. But this person basically, they already wrote their part of the script. And so right now, I'm rendering an animation for that video as we speak. This entire live stream, in the background, I've been rendering an animation for this video. And right now that I'm ending live stream, I'm gonna go look over that script and either make some notes or just start animating for it. And that's why this video will be up on YouTube in a couple of days. So, is it a bigger or smaller channel that you're working with? I think bigger. Yes, bigger. I don't remember the exact number, but yes, bigger. But that's not important, honestly. When it comes to this channel, I'm just a fan. I'm just straight up a fan. And it's also professional. No, they're not. No, it's not Prussian blue. But this is gonna be a really cool video, and I'm really excited. What I'm mostly excited about is that are they in the EU? I'm not gonna give you like all the answers. Looking at the chat, I know what I'm watching tonight. Yeah. What I'm mostly excited about is that this person is an actual like expert, actual honest to Lord above expert, which means that I just gotta say, you know, making a video with an expert feels so much better. So much better. I'm gonna do it way more often now. From now on, I'll just work with experts, because it's fun. Anyhow, I feel like it's about time we end the live stream, right? We've got an actually surprising amount of progress done today, and it's been a 2-hour-long live stream. Hey, we're actually doing the daily streams on the main channel, not other channels. That's neat. Anyhow, I'm gonna go for now. Plenty of videos to do, plenty of animations to make. And I suppose for now be it. I think it's time to go. Alright, bye-bye, make it. Think about the Forge and Lab. Yeah, it's gonna be my motivation. Whenever I'm feeling demotivated, I just think about the lab. It gets me going. Yeah, I mean, I could build a lab. I just would like to get more space first. Because I'm still living in a temporary state, let's just say. I do plan on moving soon. That's kind of why I'm pushing my Patreon so hard, because I need to move. Long story short, for now, that'll be it. Thank you, everyone, so much for watching, and have a great day. Bye.